In this video, we're going to be talking about what independence means in probability theory. And to do that, we're first going to review our multiplicative rule of probability formula. So that was the probability of events A intersect B, so event A intersect B, is equal to the probability of event A times the probability of event B given A. So if we're going to say events A and B are independent, so we're going to say A and B are independent. Our formula changes slightly. Our formula now becomes the probability of A intersect B is equal to the probability of A times just the probability of B. So what this means is that the probability of B is equal to the probability of B given A if A and B are independent. So we can say that the probability of B is equal to the probability of B given A if A and B are independent. In order to really understand what independence means in probability, it's generally easier to walk through some examples. So for our first example, we're going to say that event A is that coin A is a heads, and event B is going to be that coin B is heads also. So we have coin A is heads and coin B is heads. So we know naturally that these two events are actually independent, right? If we have two coins and we're flipping them independently, we know that what their actual outcome is going to be is independent of the other one. So that what happens in coin A does not affect coin B. So to calculate the probability of A intersect B, so we have two heads in our coin flips, it's just going to be equal to the probability of A times the probability of B. So if we calculate that, probability of A is 1 out of 2 times the probability of B, which is also 1 out of 2, so we get 1 out of 4 for our probability of flipping two heads in two coin flips. For our second example, we're also going to have two events. We're going to have event A is that we draw a queen, and event B is that we draw a red card. And we're going to try to determine if these two events are independent. So remember, for our definition of independence, we're going to say that the probability of A intersect B is equal to the probability of A times the probability of B. But we know from originally that our multiplicative rule of probability formula tells us that it should be equal to the probability of A times the probability of B given A. So we just need to check to see if the probability of B is equal to the probability of B given A. So is the probability of B equal to the probability of B given A? And that's what we're trying to determine. So let's look at how we can figure this out. So we have the probability of B is that we draw a red card. So we know that the probability of B is equal to 26 over 52, since there are 26 red cards in our deck of 52. And then the probability of B given A is equal to the probability of A intersect B divided by the probability of A. So the probability of A intersect B is how many queens are there that are also red cards. So we know that there are only two queens in our deck of 52 that are red, so we can say 2 over 52. And we divide that by the probability of A, which is that we have a queen, so we have that as 4 over 52. So we can then simplify our fraction and get, we have 2 over 52 times 52 over 4, which is equal to, if these two cancel, we have 2 over 4, which is equal to 1 over 2. And we know that 26 divided by 52 can be simplified into 1 over 2, which is equal to our 1 over 2 from over here. So we can say that the probability of drawing a queen and the probability of drawing a red card are actually independent events.